Recently, an interval on chromosome 10q22-24 was identified to be linked to atrial fibrillation, dilated cardiomyopathy, hyperplastic left heart syndrome, and neurological disorders. The gene KCNMA1, encoding the alpha subunit of the large conductance calcium-activated potassium channel KCA1.1, maps to this region. However, insights into the cardiac functions of KCA1.1 are limited, and KCNMA1 has not been investigated as a candidate gene for AF. Here, Pineda et al. Aim to establish KCNMA1 as an AF gene. First, they sequenced 118 patients with familial AF, identifying a pathogenic variant in an index patient. Next, they further elucidated the role of KCA1.1 in normal cardiac structure and function in humans, mice, zebrafish, and fruit flies. The complex KCNMA1 variant was identified in one kindred with paroxysmal lone AF at 34 years of age, development of features of tachybrady syndrome with sinus bradycardia, frequent sinus pauses, and permanent AF. The variant was absent in the NOMAD population database. To evaluate potential disease mechanisms, Pineda et al. Evaluated the distribution of KCA1.1 in normal hearts from humans by immunostaining of right atrial tissue sections, revealing co-localization of KCA1.1 with the ryanodine receptor and connexin 43, as well as strong expression in the sinus node. Knockdown of the KCA1.1 ortholog KCNMA1b in zebrafish embryos resulted in sinus bradycardia with dilatation and reduced contraction of the atrium and ventricle. Genetic inactivation of the Drosophila KCA1.1 ortholog also slowed the heartbeat and produced fibrillatory cardiac contractions. EP characterization of slow deficient flies revealed bursts of action potentials, reflecting increased events of fibrillatory arrhythmias. Flies with cardiac-specific overexpression of the human KCNMA1 mutant also showed increased heart periods and bursts of action potentials similar to the KCA1.1 loss-of-function models. The authors conclude KCA1.1 channels have a highly conserved role in sinus node function and arrhythmia risk. KCNMA1 is a candidate disease gene for AF and other human cardiac disorders. However, further studies are warranted to get a deeper understanding of the underlying mechanisms.